Welcome again to continuation of the topic trigonometry. We want to go into introduction to special angles. What do we mean by that special angles? These are angles that are special, that we don't need calculator for us to get their answers. Okay? Examples of those special angles are cos 30, sin 30, tan 30. Then cos 60, sin 60, tan 60. Then cos 45, sin 45, and tan 45. Want to derive these angles first. How to get it first? After it, we go to graph of sine and cosine, and see how we can also use the graph to interpret the angles there. Okay? Now, when you talk about this sine, this first two, how do we get it? You use equilateral triangle. Yes, in equilateral triangle, it is noted that the three sides are equal and their angles are equal. The three angles are equal to be 60 degrees. Now, because it is equilateral triangle, it is noted that each of the sides is 2 units. That is the size of each of the sides. Okay? Now, from mathematics, it is noted that when a line moves from the top of equilateral triangle to the down of it, it will bisect the equilateral triangle into 2 equal parts. It will divide it into 2 equal parts. That means here is 1 and here is 1. 1 plus 1 gives you back the 2. Then once you divide or bisect this angle, here the half of the angle will be 30, the other one 30. So we cannot have them this way. Here is 30 degrees. Here 2, here nothing, here 1. Here is 60 degrees, here 2, here 1, here nothing. How do we get one of these sides? Now, because here is a right angle triangle, as we said in the previous video, that when a vertical and horizontal meet, they form a right angle triangle. Without being told, you have to know that. So, what happens now is that what you do is get this side. This side and this side are the same. Get the value of it. You remember in Pythagoras theorem, here is hypotenuse because it faces angle 90 degrees. While here is adjacent. Here is opposite because it faces the given angle. Now from Pythagoras theorem, it says that C, the hypotenuse square equal to opposite square plus adjacent squared. So opposite is given to be 1 in this first diagram A. This is diagram A, while this is diagram B. This is A and this is B. So what you do now is you say 2 square is equal to opposite is what? 1 square plus adjacent is what? That is what I am looking for. 2 square 4, then 1 square go the other side minus 1 equal to x squared. Therefore, it implies that x squared equals to 4 minus 1, 3. Therefore, x equal to square root of 3. It means here is square root of 3. Come to the other side, here will also be square root of 3. Because the 2 sides are equal. That is from this middle line that we get these 2 sides. Now we've been able to derive this. Now from this first triangle A, they can ask you get cos 30. Cos 30, sin 30, and tan 30 can be gotten from triangle A. Then what you do is I say cos 30 means cos from car. Adjacent over hypotenuse. Where is our adjacent? Here is hypotenuse. here is opposite, and here is adjacent. So, adjacent over hypotenuse, adjacent over hypotenuse, that will be giving you root 3 over 2. You come again, sin 30. Sin 30 can be getting from so. This so is opposite over hypotenuse. Opposite over hypotenuse. That is 1 over 2. Then tan 30. This is getting from 2. From previous video, we noticed that there is what we call soca 2. Okay? So tan 30 opposite over adjacent. Opposite over adjacent. That will be 1 over root 3. So rationalizing it, because denominator cannot be in short form, that will be giving you root 3. That will be giving you 1 over root 3 times root 3 over root 3. The denominator cannot be in short form. That is why we are rationalizing. That will be giving you root 3 over 3. So therefore, sin 30 equals to 1 over 2. Cos 30 equal to root 3 over 2, and tan 30 equal to root 3 over 3. You note this. We got them from equilateral aspects. Then after getting this, we now clean to get the one of cos 60 sin 60. So, we write what we got here, sin 30 equal to 1 over 2, cos 30 equal to root 3 over 2, tan 30 equal to 1 over root 3, or root 3 over 3. Then we come to the one of cos 60. We say cos 60 is gotten from car. Cos 60 is gotten from car, or can be gotten from car, which is what? Go to triangle B, because you have angle 60 there. You now say adjacent. Where is my adjacent? Here. Because it joined this hypotenuse to form the angle 60. Adjacent over hypotenuse, 1 over 2. Then sin 60 is getting from so. Sin 60 opposite over hypotenuse. This is opposite, because it's facing the given angle. So equal to root 3 over hypotenuse is 2. Then tan 60 is from 2 that we get it. Opposite over adjacent. Opposite over what? Adjacent. That is root 3 over 1 equal to root 3. So we've been able to get this as well. We say our cos 60 equal to 1 over 2, sin 60 equal to root 3 over 2, and tan 60 equals to root 3. We come again. We go to the last one, which we call cos 45, sin 45, and tan 45. Cos 45 is gotten from car. That is, how do we get cos 45? You can't get cos 45 from here, because there is no angle that is 45 here. You go to a unit shape. A unit shape. One of the unit shape we have is square. When we talk about unit shape, the four sides are meant to be equal. Equal to 1, equal to 1, equal to 1, equal to 1. Then, when you get a diagonal line, you will be having this, where here will be angle 90 degree. Here is 1, here is 1. You can see it. This is the side we are talking about, the triangle we are talking about. Now you see apply, it said, if the angle is here, you know, everything here is 90. So once you bisect this angle, it will be giving you here to be 45. Here 45. Just take one, because here 45, here 45, they are the same. Then you now remember that this is a Pythagoras theorem that can be applied here because this is a right angle triangle. Pythagoras theorem is only applied in a right angle triangle. So this right angle triangle, you now say, from Pythagoras theorem, here is hypotenuse, okay? Here is adjacent, and here is opposite. Because this adjacent join this hypotenuse in forming the angle 45. Then we now say hypotenuse square from Pythagoras theorem equal to opposite square plus adjacent squared. What is hypotenuse? We are looking for it. Opposite, 1 square plus 1 squared. X squared equals to 2. X equal to root 2. We now have here to be root 2. We say we are done. Then the implication is that we now say cos 45 can be gotten from K. Adjacent over hypotenuse. What is my adjacent? 1. What is hypotenuse? Root 2. That is, when you rationalize this, you give 1 over root 2 times root 2 over root 2. That will give you root 2 over 2. Okay? You now say sine 45 is gotten from so, and that is opposite over hypotenuse, 1 over root 2. Still same with this, that will be also root 2 over 2. It means that when you press sine 45 in calculator and when you press root 2 over 2, they will give you the same answer. Then you come again and you say tan 45. Tan 45 is gotten from 2. Opposite over adjacent. Opposite over adjacent. 1 over 1 equal to 1. You write cos 45 equal to root 2 over 2. Sin 45 equal to root 2 over 2. Then tan 45 equal to 1. We have been able to derive this. Now, let's see our analysis. Let's see our conclusion from these derivations we have done. From this, do you notice that sin 30 is equal to cos 60? Yes, we said sin 30 equal to cos 60 from what we got equals to 1 over 2. Note it. Do you notice again that cos 60 is equal to sin, cos 30 is equal to sin 60. Cos 30 equals to sin 60 equals to root 3 over 2. Do you notice again that cos 45 is equal to sin 45 and equal to root 2 over 2. Then, what else? We have seen all this now. Now, note that inverse of sine, 1 over sine theta is giving you or should give you cosec theta. This is inverse of the sine angles. 1 over cos theta will give you sec theta. We call it secant theta. This is cosecant theta. Then 1 over tan theta will give you cotangent theta. Okay? So what you now do now is that you say this is inverse of this. This is inverse of this. That tells us that analysis here we need to know is that cosecant theta from here. Cosecant theta means 1 over this is equal to sec 90 minus theta. Let's write it well. We say that from this analysis we have here, it is telling us that 1, that when you have sin theta, it will be equal to cos 90 minus theta. That means when we have theta to be 30, this will be 90 minus 30, 60. Then cos theta is equal to sine 90 minus theta. That is what here is telling us. Then also note that tan theta is equal to cotangent 90 minus theta. Then from here, we can also say that sec theta is equal to cosec 90 minus theta, because inverse of this will give you sec theta, and inverse of this will give you cosec theta. So it's still applied there. Then that also means that cosec theta is equal to sec 90 minus theta. Okay, that is for this. So we have to note all this. This is about inverse of the trigonometrical ratios. Okay, we have to note it. If you bring your calculator and say sin 30 equals to cos 90 minus 30, sin 30 will be giving you cos 60. Cos 30 will be giving you sin 60, because 90 minus 30 is 60, and that is same with others. Okay, so that is it. Please see the next video so that you see the graph that we can use to explain sine and cosine of this topic. Okay, thank you for watching the video. Please don't forget to subscribe to my YouTube channel and like my video. See you in the next video.